The geology of flooding. By the end of this video, you should have a better understanding of the geological factors that are key behind flooding's occurrence. While it's a case that these factors that contribute to flooding are similar to those factors that contribute to landslides, the focus of this video is primarily on flooding. Now here are some key terms you should be aware of. Porosity. This is a measure of the void spaces in a material like rock or soil that's calculated as a ratio of the volume of these spaces to the total volume of the material. It indicates how much a rock or soil can hold fluids like water. Permeability, a measure of the rock or soil's ability to transmit fluid like water. It refers to how easily these fluids can flow through the interconnected pore spaces within the material. An example of a highly permeable geologic material is sandstone, and an example of a geologic material with low permeability is clay. Now in this image, you are seeing a road that these hikers are walking on. This road is also an impermeable layer, albeit it's man-made. So in this respect, surface runoff of the water itself is much more high relative to it being soaked into the pore spaces themselves because of compaction. This image gives a great representation of the difference between porous, permeable, porous, non-permeable, non-porous, non-permeable materials. So as an example, again, porous and permeable material, sandstone. Porous, non-permeable, clay. Non-porous, non-permeable could be tarmac or paved roads. Other terms you should be aware of. Stream gradient refers to the slope of a stream calculated as a vertical drop in elevation over a horizontal distance. It is a key geological factor which influences erosion and flow. So in other words, it gives us a greater understanding about the speed at which, say for example, a body of water can travel, the erosive force of that said body water or body of water, and the time it may take for this body of water to develop this kind of erosive force. Slope. In geology, it is considered as an inclined ground surface, such as a hill or mountain. The study of slopes is fundamental to geology because of the key landforms and pathways for energy and mass transport, influenced by processes like erosion and weathering. Now, water is a key erosive and weathering force. So basically, the concept of stream gradient and slopes, or us having the capacity to recognize the interconnected play between slope and stream gradient, gives us a better understanding about the overall erosive force behind that body of water. If it's a case that the slope of the land is relatively flat, then we should anticipate or expect that the erosive force of that body of water will be less relative to that erosive body of water coming from a slope that pretty much is much more inclined, which then triggers or contributes to the stream gradient also being much more higher. And water table. This is the upper surface of the phreatic zone or the zone of saturation. The zone of saturation is where the pores and fractures of the ground are saturated with groundwater. So the river, once we can see the river, this is a representation of where the water table is. And basically speaking, in the context of when we have times of rainy season or bouts of heavy rainfall, the expectation is that the water table will rise, and this gives a representation or is represented by the rise in flood waters or rise in the elevation of the river. So in that context now, by having the understanding about where the water table is, it gives us greater understanding in the areas of development planning, hazard and disaster preparedness or mitigation or management overall as key examples. Where I now take you is into extrapolating some of these terms uh, towards the overall geographic reality of areas, and my focus area is that of Jamaica. Now, where I'm going to begin is with this geological map that is provided by Professor Simon Mitchell. The key thing for you to keep in mind is that throughout the entirety of Jamaica, the geology is a key influencer behind the flooding capacity or the flood prone areas being what they may be from a parish level to the overall national level. So, the basic understanding from this surface geological map, we can see some rock types or lithologies. And I'm going to make it as easy for you to understand in the context of flood bearing or the flood prone capacity of these lithologies. Alluvium, which is in the green areas, these basically, or as a lithology, it can be considered as unconsolidated, which means that it generally will have a much more permeable as well as porous nature relative to clay. And as you can see on this geological map, there are alluvium areas in Kingston, St. Andrew, St. Catherine, Clarendon, St. Elizabeth, Hanover, Westmoreland, St. James, Trelawney, St. Mary, St. Thomas. Now, coastal group. Now, as a general lithology, it is like a mixture between carbonate material. Carbonate material could be limestone, and it basically has a lot of fossils within them. And this lithology is considered to be not highly compact, so it tend to be porous, and it may also be permeable. So we can see coastal groups basically throughout the coastal areas of Jamaica, generally speaking. Um, but as this geological map represents, we see them primarily in the areas or the parishes of St. Thomas, Portland, St. Mary, St. Anne, St. James, Westmoreland. Yes, those parishes primarily. Next now, we have the Cretaceous inlayers. And the Cretaceous inlayers are the igneous rocks, generally speaking. And igneous rocks, uh, as highly crystalline, or basically those rocks with the general nature of having much more compact crystals, minerals themselves, are not as permeable, and in that respect, it basically is not going to allow fluid to flow through as readily compared to sandstone areas or alluvium areas. So we can see these zones, igneous zones, centrally within the parish of Portland. We can also see them somewhat central within the parishes of St. Mary and St. Catherine. See them central within the parishes of St. Catherine and Clarendon. Similarly, somewhat central in the parish of St. James. And lastly, basically getting somewhat coastal to central within the parishes of, or rather within the parish of Hanover, and somewhat central within the parish of Westmoreland. Yellow limestone is generally considered as a mix of carbonate and non-carbonate material. So it can have some layers that can prove to be clay-like. So the yellow limestone group can be porous, but not necessarily fully permeable. So in that respect, it basically can move somewhat in a way where it contributes to flooding in certain areas. So we can see the yellow limestone group that surrounds the igneous group, which again, the igneous group is somewhat blue, or consider this area as the blue area. So we see the yellow surrounding the blue area, which basically then is suggesting that in terms of, let's just say, the runoff, it is going to be relatively high in these areas, yellow limestone group areas, because they will be somewhat underlain by the impermeable igneous rock areas itself. So the yellow limestone group, we can see that in St. Mary, Clarendon, St. Anne, St. Catherine, St. James, Hanover, and sections of Westmoreland. And the final lithology is the white limestone group, and this is highlighted in the areas of blue and gray. Now, generally speaking, white limestone group tends to be uh, porous, and it also can be somewhat semi-permeable. Now, bauxite is somewhat associated with white limestone group areas, and in that respect, it pretty much is a case that white limestone group areas uh, tend to have the good flow of water going underground. Now, whilst I have mentioned the lithologies, it is also key for me to highlight the contribution of fault zones. And these fault zones, we can see them as these somewhat burgundy uh, lines. So the extent at which fault zones contribute to, let's just say, porosity or permeability is extensive. This these fault areas basically fracture rocks, and in essence it basically allows for fluid to go through the cracks of the rocks themselves. So the the reality is that fault zones are a key secondary porosity and even permeability contributor for fluid flow throughout the landscape of Jamaica. I now turn my attention to the terrain features, geographically speaking, across Jamaica. This now adds another layer towards your understanding as regards to the geofactors that are contributory to flooding occurrence from a parish by parish level. As I go along, I will also link the underlying lithology to give you a better understanding of the flooding capacities. The parishes that we are focusing on here is that of Portland, which is more so to the north, northeast, and segments of northwest of this image. If you look centrally on this image, we can see that it pretty much highlights a lot of ridges, and these ridges is an expression of the mountainous nature of the inliers or the inland area of Portland. Uh, no, the underlying lithology, if you recall, is that of igneous, generally speaking. So, with a high elevation, uh, as well as the fact that we have underlying lithology being igneous, we basically have a lot of uh, runoff in the form of rivers. And these surface rivers basically are key flooding zones or sources when it comes to times of heavy rainfall. To the south, east southeast, and segments of west southwest of this photo, we basically have St. Thomas. And you should see that there also exist segments of the ridges, and that basically suggests that segments of St. Thomas is mountainous, and there also exist those areas that are relatively flat. So, in that respect, we should expect that St. Thomas, given its underlying lithology, having segments of igneous as well as the coastal group as well as alluvium, will also experience river flooding, and basically can also experience a degree of flooding that is contributed by the storm or sea level rising in the events of storm. So, storm surges or coastal flooding as examples. Northwest of this image is that of St. Mary, and St. Mary is highly mountainous as well. So river flooding is a key area of flooding for this parish. Uh, we look as well to the southwest of this picture, and we're seeing that gray segment, and this gray segment is representing the parishes of Kingston and segments of St. Andrew. And this area is mostly going to experience urban flooding. So paved roads pretty much is the man-made contributory behind this nature of floodings are taking place in these parishes. As we look at this image here and looking specifically to the west of the image, so we're speaking about the southwest, the northwest, the west of the image, so moving west overall. What it is now you should see is that there is a general reduction in terms of the mountainous nature uh, for these parishes, and these parishes are represented by St. Catherine, segments of St. Mary, St. Anne, and as well segments of segment of Clarendon. I want you to now take your eyes and focus on the area of Linstead. Via this terrain map, what it is that you should see is that there is generally a sinking or a depression where Linstead is located relative to, let's just say, the immediate surroundings. And this depression gives indication as regards to the nature of flooding that can take place in Linstead. So you can have water that is coming from the elevations surrounding Linstead itself being deposited in Linstead, because Linstead exists somewhat like in a basin. And in the context of the underlying lithology, even though Linstead should have white limestone as the dominating lithology, the bauxitic nature of the unconsolidated material can make it become somewhat clay-like. So in other words, it can become impermeable. And in essence, that will then mean that drainage of the floodwaters in Linstead can be relatively slow compared to underlying lithologies that are not as impermeable. Now, for sections of St. Mary, such as Port Maria and other coastal areas, such as in Anato Bay and moving into St. Anne, Ocho St. Anne's Bay, Runaway Bay, these locations can experience inundation or flooding as a result of urban flooding and the fact that from the geo-factors point of view, the relief surrounding them uh, basically have the dumping of water from higher elevations to lower elevations. So it's like a double whammy, if you will, of having urban flooding factors as well as the fact that you are existing on a relatively lower elevation compared to higher elevation, which is where the runoff will be coming from. The inland areas of St. Anne and Trelawney uh, don't really reflect by the terrain map key flooding surface wise. Uh, and basically, the white limestone underlying lithology will support that the bulk of the drainage will go underground. So, basically speaking, it's underground rivers that predominate within these central regions of these parishes. Moving into Trelawney and Hanover, we can see that there exists areas of flat, also areas of grey, which is the urban areas, and areas of higher elevation, which pretty much mean that yes, you can have runoff from the areas of higher elevation, albeit the runoff could also be coming from underground sources, and they then now will be contributory to the flooding being a double whammy in the context of urban and non-urban floods. Similar is the case for Westmoreland and St. Elizabeth. We have a higher our regions of higher elevation and regions of lower elevation, and basically we can have the outpouring of water from the high elevation areas into the areas of lower elevation. That would be key contributory to flooding taking place in those areas. And as we get closer to the coastline, we then now can have coastal flooding taking place. St. Elizabeth, rather Santa Cruz in St. Elizabeth, like Linstead, can also experience flooding that is somewhat attributed to the reality that it is located somewhat in a basin-like region of the parish. Mandeville, though located or situated on underlying lithology that is that of white limestone group, basically can experience urbanized flooding because of the high built up areas that make up the Mandeville town itself. And finally, the latter half of the parishes of Clarendon and St. Catherine can experience coastal flooding as well as river flooding because of the relatively flat terrain of this region. This region basically is at sea level height. So, in the context of storm events, when you have storm surges, the height of the waves can go far inland. And in the context of rivers being inundated, it pretty much can spread relatively far in terms of its width, thus resulting in extensive flooding for those persons or communities located along or within that alluvial plain itself. All that I have done here up to this point is to highlight to you the key contributory factors, geologically speaking, behind flooding's occurrence. And in so doing, I highlight to you the challenging or the complex interplay in the context of underlying lithology, uh, human interaction or human land use, as well as terrain. This interplay makes it somewhat of a tricky uh, reality of planning for development. Now, where you are concerned, you should now be taking this information towards assisting you in making better informed decisions as regards to where you build, where you invest, basically where you live. By having an understanding of the underlying ethology, by having a clear understanding about how by you altering the landscape, say for example, by removing the natural vegetation, or you, say for example, removing or changing the overall landscape itself in terms of its the slope gradient, etc. By doing these or altering the landscape in these ways, you are in essence contributing to the flooding capacity being increased, say for example, specific to your property in terms of being a major hazard to your property itself and or to the community slash communities in which you reside or which basically reside near to where your property is. That is basically at the very basic, the core behind you having this knowledge or this insight.